Oh, hi. Our topic is force on a moving charge in a magnetic field. Now, let us say we have a magnetic field denoted by B. B is the symbol for magnetic field. Now, we have a magnetic field acting along positive x-axis, and we have a charge plus Q at this point, plus Q. Now, this charge is not moving at all. It's a stationary charge. Now, we find that when the charge is stationary, there is no force acting on the charge. Let us say we give a velocity to the charge, and the charge moves in this direction, v. Yet we see that there is no force on the charge. No matter how much we increase the velocity, there is no force on the charge. Let's summarize. When velocity of the charge is in the same direction as when velocity is in the same direction is in the same direction as B, there is no force acting on the charge. Same direction as B, the force on the charge is 0. Now suppose we give a velocity in some direction, in this direction, making angle theta with B. Now what do we see? We see that there is a force acting on the charge, and this force acts in this direction. Okay. Now, if we increase this angle theta with the B, if we increase this angle theta, which means the charge now moves in this direction. Okay, angle between the charge and between the velocity and B has increased. Now we see that force increases. If you increase theta further, force will increase more. Finally, okay, when theta is along y-axis, which means when the charge is moving perpendicular to the magnetic field, the force on the charge is the maximum. Force is maximum. Now this means that as you increase angle theta, force increases as theta increases. Force is 0 when theta is 0. So this means that force is actually proportional to sine theta, because force is 0 when theta is 0, sine 0 is 0, and force is maximum when theta is 90 degrees, so sine is maximum when 90 degrees. So force is proportional to sine theta. Now it is also found that if you keep the force constant, if you keep theta constant and B constant, you see that force will also increase as velocity increases. Similarly, force also increases as B increases. Now very simply what this means is that as I increase V, okay, I keep theta constant but I increase V. As I increase V, keeping theta constant, what happens? The force increases. Similarly, as I increase B, keeping theta constant, keeping velocity constant, again force increases. So now I can say that force on the moving, that in a magnetic field, a moving charge will experience a force. If the charge is stationary, there will be no force. So I can say that F, or this I can summarize as F is proportional to Q V B sine theta. We will see that force is also proportional to charge Q. So F is proportional to Q V B sine theta. Or F, now we choose the units in such a way that our proportionality constant becomes equal to 1. So F is Q V B sine theta. Now I repeat, This is a proportionality sign. Now, proportionality sign, by choosing our units, by choosing units of B, V, Q in such a way, we can make the proportionality constant equal to 1. So our formula becomes F equal to qvB sin theta. And as we have seen before, as I mentioned here, that F is also proportional to charge Q. So F is proportional to velocity, F is proportional to B, magnetic field, F is also proportional to charge Q. Yeah, so Q is the charge, V is the velocity, and B is magnetic field. B is magnetic field. And V is the velocity. V is the velocity. Now, how do you obtain the direction of the force? Now, direction of the force is obtained from right hand screw rule. Right hand screw rule. Now, what is right hand screw rule? If I say my velocity is in this direction, velocity, and B is in this direction, now if I move a screw from V to B, then when I move the screw from V to B, the screw will go inside. So the direction of the force will be this, F. Okay. This is right hand screw rule. Now let's see some examples. Okay, let's say we have a bar magnet here, North Pole and South Pole. Now, we all know that a magnetic field between a bar magnet will be from North Pole to South Pole, magnetic lines of force. So this is the direction of magnetic field. Now I place now there's a charge which is moving in this direction. Let's say in this direction. Charge is moving in this direction. Is moving in this direction. Now, when the charge enters the magnetic field at this point, there will be a force acting on the charge. Now, what will be the direction of that force? Now, I will draw X, Y, and Z axis. Now, my B is in this direction, V is in this direction. So, V cross P, when I turn a screw in this direction, in the clockwise direction, the screw will be pushed down. So, force will act in the downward direction. Correct? Let's see some more examples. Let's take one more example. Let's say we have an ion, a positively charged ion, which is entering a region, which is entering this region, and then it turns like this. Now we know there is a magnetic field acting here in this region. Now what is the direction of the magnetic field? We have to find the direction of the magnetic field. Now what do we see? We see that the charge is moving in this direction and it is turning in this direction. Okay, which means in the plane of the paper. So there is X axis here, Y axis here. The charge is moving, turning in the plane of the paper. So the force can act either inside into the paper or outside. Now if the force were to act outside the paper, B, I mean if magnetic field is outside the paper, then V cross B would be directed in this direction. Yeah, the force would be in this direction, which is wrong. Therefore magnetic field has to act in this direction, into the field of the paper, so that the force acting V cross B will be in this direction, which is what we see. Okay. Thank you.